Good morning, students. In this lecture, we are going to solve one problem in the analysis of asynchronous sequential circuit. Right. Now, I read the problem. Right. An asynchronous sequential circuit has one primary input. So here, one primary input. So you take that one primary input is X, one input and two internal state. So internal state is here we are having now this is a secondary variable y1, y2 and one output, right? So this is one output is Z, right? Then two excitation function and one output function describing the circuits, right? So this is two excitation function, right? Okay, here we are having now the two excitation function, right? Y1 and Y2 and one output function. Now you have to draw the logic diagram of the circuit and then you have to derive the transition table, output map and obtain the flow table for the circuit, right? Now how do you start now? So here we are having now y1 and y2, then we are having now that one AND gate, then we are getting now that OR gate. So here we are having now the output is here we are having this is plus, this is plus. So you draw two OR gate. First you draw the two OR gate, one, then another one OR gate. Sorry, sorry, you have to draw two OR gate, right? Two, one OR gate, then another one OR gate. So this is y1. You take that one as capital Y1, excitation variable Y1, capital Y2. Okay. Now here you see this one, this Y1 is feedback path. Y1 is feedback path. So here we have to take this as a feedback and this feedback path is connected with one AND gate Y1. So here we are having now one AND gate because Y1 and X1 bar, right? So X1 is we are taking that external input X1, X. This X is inverted because of the X bar and you have to give it to 1, right? Then this is one input of that OR gate. This is AND gate, right? So this is OR gate. So OR gate is plus, right? Then here we are having now one AND gate. So one term is okay. X bar Y1. So this is Y1, secondary variable, small Y1, right? So this is a capital Y1 is excitation variable. This is a excitation variable. This Y1 is secondary variable. This Y1, small Y1 is a capital Y1, right? So this is a capital Y1 is excitation variable and small Y1 is here we are having now second a present state or secondary variable. Then here X is inverted and you are getting now X bar. So this is X bar, this is Y1. So we are getting now one term X bar Y1. First term is over. Then plus Y2 dash. So you take that Y2. Y2 is feedback path. So here you have to take that feedback path from Y2, right? Then you have to do that one as one inverted because one inverted input, right? So inverted, then you are getting now y2 dash. Put it into that one, right? Y2 dash. So this function is over. So that circuit is over. Now the second one, here we are having x plus y1 dash, x plus, right? X plus y1 dash y2, right? So y1 dash. Y1 dash is here. You take this one as Y1. Right? So take from that tab Y1. Y1. This is Y1 inverted. y1 inverted as one input, y1 dash, and you are taking now that one as y2. So this is y2 in that path, right? So this is y2. So you take that y2, then you have to connect with AND gate. Then we are having x plus. So directly you have to get that x. This is one input, and you are getting from one x. You have to take that one x. X is another input for that AND gate, right? So directly x is another input for that OR gate. Now we are getting now y2. Next, we are having Z as in output, right? So that is we are having now, right? So that one is here, Z is output. So you are having now three input AND gate. So three input AND gate. You take that AND gate, right? Then we take now X, Y1 and Y2 dash, right? So X, Y1 and Y2 dash. So this is we are having now Y2 dash. So you take that already inverted output is there. You directly you get that inverted output y2 dash. Then we are getting now from one y1, y2 dash, y1, and then we are getting now that x. So this is the x continuous. So you have to give that one to x. Now this is the z. Z is here y2 dash. So x you are taking from x. This is you are taking from y1. Then x, y1 and y2 dash. So this is a logic circuit. Logic circuit. Right? Then here we are having logic circuit or logic diagram, right? So draw logic diagram is over. Now we have to get the transition table, right? So now how do you get the transition table? Here we are having now that one as x. Here we are having y. Here x y1 y2 y1 y2 in the row wise, that is as a present state, and the output is here input is x, input is x, right? So present state input x, then you have to write for that y1 function and y2 function. This is the 0 0 0 1 1 1 1 0. This is x equal to 0, x equal to 1. Right. Now here within using the function itself, then we have to fill function itself. We have to fill it now. Then here we are having now y2 dash, right? Right. Y2 dash is here. We are having now this y2 dash is this one. Y2 dash. So x is not there. So only we are having y2 dash. In that function, we are having y2 dash. So x may be either 0 or 1. So you have to fill all are 1. So this is 1, this is 1, this is also 1. Because we are having now, sorry, y2 dash. Okay. Y1 dash and 2. right? Here we are having now that y2 dash, right? Y2 dash is this 0. 0 is y2 dash. 0. So in that row you have to fill. In that you have to fill 1 1. So this is for y1 table, right? So this is y1 table. So this y1 table is here. This is the y1. So the y1 is here. We are having that y2 dash. So y1 is equal to y1 equal to, here we are having now x1 x1 bar y1 plus y2 dash. So this is the function, right? So that using that function y2 dash, using the function, right? So y2 dash is there. So that is y2 is 0. Then on that one, you have to on all row, right? So this is y2 is 0 and y2 is 0. All rows you have to put value 1, 1, 4 rows. Then here we are coming x dash y1. So x dash y1 is x dash y1, right? So that x is 0. At the same time, y1 is 1, 1. So this is 1, 1, right? So that is here, these are all 1, 1. Then all others are 0. You carefully to that one, right? Or otherwise, so you have to introduce, so you have to write that one as this expression. Then what actually we have to do is y1 equal to x1 bar y1 plus y2 dash, right? Then here we have to fill this 8 column, right? In that 8 column, how do you fill that one? Y2 dash. Here we are having now y2 dash y1 is missing and x1. So here we consider now only the y2 bar is 0. So wherever we are having 0, so all row, wherever y2 is 0, you all row you have to fill 1 1 because of this term, right? Here we are having x dash y1. X dash y1 is here. X dash should be 0. Y1 is 1, right? So that location you got. So x dash is 0 and y1 is 1, 1. So this 1, 1 is here and x dash is 0. So you have to fill this one and this one, right? Already we are having 1. So 1, 1 we have to fill, but already we are having 1. So you leave it 1, 1. So this is the y1. Next y2. Capital letter y2. Excitation variable, this y2. Y2 is the next function. So here you have to draw another map table. Right? So in that map table, here we are having 0, 0, 0, 1, 1, 1, 1, 0. This is 0, 0, right? So this is small y1, small y2. This is x. Right. Now in that y2 function, we are having x itself. So wherever the x is 1, so this is 1, right? Here, this is y1, this is y2, this is x is 0 and 1. So wherever x is 1, right? So you put now 1. So you put all are 1 here, right? Then here we are having now x bar y1. X bar is 0, y1 should be 1, right? So these two are 1, 1. Then all others are 0. All others are 0. Now you have to write the transition table. Right, so the transition table is here you merge together, right? So that is 0, 0, x is here 0, 1. Then you have to draw that one as here. Okay, here now you see this one. 1, this 1 and 0. So this is 1, 0. This is we are getting now 1, 1. Next we are having 0, 1. 0, 1. So this is y1, y2 combined. Capital Y1, capital Y2. Next, so this is a 0, 1. right? So here you write that no need to write that gray code. Just you can 11 10 11 also we can write, right? So that is here. So this one is here 0, and then here this also 0 1, and then 10 10 is this one, right? 10 is this one, 10 and 11, and then here we are having 10 10. Oh, sorry, here 11 01, right? So here whatever the same one, if you are having now, you draw circle. So here we are having circle. These are the stable state. Then 10, the 10 is max, so the stable state. So when the stable state is small y1, y2 is equal to capital Y1, capital Y2. So small y1, y2 equal to capital Y1. So this one. Right here we are having 1, 1. So these are all the stable, right? So circle is stable, then all other parts are unstable. So this is unstable. So here we are having that in y1 y2 is 0 0, then it won't go for 0 0 for either input 0 or 1. It will go to another state, then from the state it may go to the stable state. So two most of it will go for stable state, right? Then we are having we have to draw the float table. So float table, and we have to draw the float table, right? So that one as here. How do you draw the flow table is you have to give the name. So this is A, this is B, this is C, this is D. So we are giving that value, right? So that binary value is going to map into a label. So label is here A, B, C, D. So input X is here X 0 1. Then here it will go for directly you write instead of that value, then you put the label. So A here 10 is C, 10 is C, then 11 is D, then B by 0 it will go for B itself, and here it will go for B itself, both are same, right? Then here 10 it will go to C, and 11 is D, go to D, then from D it will go to D itself, then here 01, that is B. So what it is actually, from state A, by input is X, input X is 0, then it will go to C. Right? Then from the C, if input is 0, then it will go to C itself. 0, it will go to C itself. So here A to C and C to C. C is a stable state. Like it will go, right? So this is a float table. Flow table with the output, right? So that output is here, right? Transition table and output map, right? So the output map is here. So output is here 3 zeros. So the output is here x y1 y2 dash, right? So that is y1 y2 dash y1, you write that y1 dash y1 dash y2 sorry y1 y2 dash y1, that is here y1 y2 dash x, y1 y2 dash x, right? So at x y1 y2 dash x, then at what time then the z is 1, 101 is z1, all other cases z is 0. So that is the output table is here for that same inputs, right? The output table is here. I draw that output table where. So this is a transition table with output means here. How do you write that one? 100. Then put that this is a transition comma the output, right? Or otherwise you write in float table, right? C1 comma. So in the table, right? So A, B, C, D, right? So this is X is 0 and X is 1. Then here you are writing now that one as flow table with output, right? So our transition table with that output, right? So that is here we are having now here C comma 0 and D comma 0, like here, right? So or otherwise you write it here itself. So it's 1 0 comma 0, 1 1 comma 0, then here 0 1 comma 0. So I'll write that one once again. I delete it and write. This is best. Right. Now transition with output, right? Transition table with output. Transition table and output map, right? Transition table and output map. So this is the transition table. Then and output map is here. We are having now that 0 0, 0 1, 1 0, 1 1. Then we are having now that for 0, for 1. So you draw that cell with length. Why it is actually we have to write the state as well as output. So the output is only in that case, right? So that is 1 0 1 only, the output is 1. All other cases are 0. 1 0 1, right? So why it is, this is a move y1 y2 dash x. So y1 is 1, y2 dash 0, and x is 1, right? So for that case only that z is 1. All other cases are 0, right? So for three zeros, we are having the 0 0 0, right? So all are 0 0, the z is 0. So that was 0 0, the state is 0 1, and then output is 0. Here the state is 1 1, this one, right? The state is 1 1, then the output is 0. Then here is state is 0 1, then output is 0, right? So that is here the state is 0 1. Here we are having now the state is 0 1, output is 0. Then here we are having 1 0, state is 1 0, the output is here 0. Here 1 0 1, the output is 1 1. Then here the transition is 1 1, then output is 1. Okay. Then here because this is 1 0 1, 1 0 1. For 1 0 1 only 1, right? Then here we are having now that 1 1 and then 0. Here we are having 0 1 and then 0, right? Now wherever the stable, you draw the circle. Stable means the state as well as the transition is same, right? Present state as well as the excitation variable is same. Then you have to draw a circle. So this is a stable. Then here this is the stable, same one, right? So this is the transition table with output map. Transition table and output map. Output map. Because the output is only at the time of 1 0 1 only 1 because of this function. So this is 1 0, right? So this is 1, this is 0, this is 1, then 1 0 1, all are here, all are 1. So at that time only we are getting now output is 1. So that is the value of that one as, so y1 y2 dash and x is 1 0 1. For that 1 0 1 only is set, right? So this is the solution for this problem. Okay, we can stop here. We will continue by another lecture.